Hello, you're welcome to my channel. My name is Loanch, and in this video we're going to deal with vector scalar product. Good. Okay, so if this is the first time watching, you may have to go back to the previous videos on the playlist to catch up with us. And if you enjoyed the video or you find it helpful, please don't forget to subscribe to my channel, share it with your friends. All right, it's a great way to encourage me to make videos like this. Good. Okay, so this right here is a really big one, vector scalar product. So we've dealt with sum of vectors, difference of two vectors, that's subtraction, and then now we're looking at product of two vectors. And when considering product of two vectors, we consider two kinds of product. We consider a scalar product, which is also known as dot product, and then we consider vector product of two vectors or more. Okay, and then we can also call that cross product of two vectors. That's the vector product. So this is only for scalar product, or you can say dot product of two vectors. Okay, all right. Now this video, what we'll really learn is the definition, and then how to use this definition to get some properties, some very useful properties of scalar product, and then we'll also understand how that applies to the unit basis vectors i's, j's, and k's. Okay, yeah. And then we'll also have some maybe representation of what is necessary just for understanding. Okay, so using this definition, we say that given two vectors, we call those two vectors A and B, and then whose directions are inclined at an angle theta, then the product of A and B is the real number. Okay, so the scalar product of the two vectors is a real number, and the real number is given by AB cosine theta. Now you could say, what is this AB, or what are these A and B? Okay, so in this case, it's just a shorthand of saying length of vector A, you just A without any arrow above it, and then length of vector B, you just B without any arrow above it, and then that. Okay, great. Okay, so we quickly just look at some properties of this, some properties, all right? Okay, so this is how to think about that. If you're given vector A, let's say vector A point in that direction, and then vector B point in this other direction. Oh, I'm coming, sorry. And then vector B point in this other direction such that the angle of inclination of these two directions is theta. Okay, so this is A, this is B. Good. So that's what this definition is all about. So some properties of scalar product, or you can say dot product of two vectors. All right, so the first property I want us to know is that dot product of two vectors is commutative. That is to say, the order in which the dot product is taken is immaterial. So if we say A dot B first, same thing as B dot A. All right, great. Now this is really easy to see. You know that the length of a vector is just a number. Okay, in that case, this product is a normal multiplication we know about, just normal multiplication of two numbers. Then it's cosine of an angle, which is also a number itself. So that is to say, the entire thing here is a number. So we know that product multiplication of two numbers is commutative. That's exactly what we can just use to get this out. Okay, so that is easy to see. The next property is that of distribution or distributivity. Now this is what it entails. If we have three vectors A, B, and C, where we have A dot the sum of B and C, all right, and don't get me wrong, these vectors have to be from the same space, all right, good. So this could be A dot B plus A dot C, just distribution. Okay, so you could really want to make sense out of this. Well, the proof of this in one of the coming videos, that is one of the next videos in this series, so you can just check that out. Okay, it's not that bad, but I can't fit it in this video to make the video to be too lengthy, even you wouldn't want to watch it. Okay, so let's look at what we can say about another property. Okay, so for the next property, I'm going to think about something. What if A and B are the same vectors? Let's say, what if vector B is the same thing as vector A? In that case, we'll have something like this. We'll have vector A dot itself. Okay, so if you have the dot product of a vector with itself, what would this become? Well, just think about it. If you say a vector with itself, so if this is vector A, okay, then vector A will also be, it could even be maybe collinear. They could be collinear, that is on the same line, kind of, or this could also be vector A. Okay, so you can see these two vectors are parallel to each other. They are the same vector, that is the point in the same direction, which means that they are parallel to each other. In that case, the angle between them could be 0 or 180 degrees, that is, could be 0 or pi. Okay, so if the angle between them is 0, using this formula, what we'll make out of that is that A dot A, it is simply the length of vector A, so you notice that, using that notation, times itself. That will mean, that will be the length of vector A squared, then times cosine of 0 degrees. Now cosine of 0 is 1. So that tells us that length of the dot product of vector A with itself is the square of its length. This is a very important result. Okay, that is if the angle between them is 0. But what if the angle between them is pi? That means the dot product A with itself, or vector A with itself, would be, well, similarly, we'll get the square of the length, that is to say, the length of vector A times the length of vector A, this second A, right? Good. Then times cosine of pi, but cosine of pi is -1, so that will give us negative of that, negative A squared. Again, now this is just the result if the how do you call it, if the angle between them is pi, that is to say if those two vectors are collinear. Okay, so that's a good thing to also know. Okay, now let's also consider special cases. That's in the case of unit vectors I, j, and k. Okay, so let's consider those. Let me just drag this down a little bit. All right, great. So what if we consider a unit vector I, that is unit basis vector I, the dot product of that with itself? Okay, so this is just any vector A. So in a special case where the vector A is this unit vector I, what would this give us? Well, from this definition, we will just have that to be the length of vector I, right, times the length of vector I, that is the second unit vector I that I'm using right here, times cosine of course, the angle between them is 0. So we say times cosine of 0, which is just 1. Now, you know that the length of a unit vector is just 1, of course, as the name implies. Unit vector, 1 times 1 is 1. So that tells us that I dot I will be 1. So we could use that to also, we could use that same method to also say that J dot J is also 1. That is to say, the unit basis vector J dot it with itself, then the unit basis vector K dot it with itself. This product will always give us 1 using that definition. This is a very, very important result, so you should take note of it. A very important one. In fact, this will help us to know how to actually compute the dot product of two vectors algebraically, right? Okay, maybe let's look at another kind of example, or another property rather, another property between two vectors. So the next property, let me see what that should be. Okay, so now we've considered a case where we have a dot product of a vector with itself, which we say those two vectors are parallel to each other. What if the two vectors are perpendicular to each other? That is to say, if we have two vectors A and B, where A is perpendicular to vector B, okay, what would be their dot product? So the dot product, that is A dot B, will be, well, given that these two vectors are perpendicular to each other, means that the angle between them is 90 degrees. So we're going to have the length of vector A times the length of vector B times cosine of 90. But we know that cosine of 90, which is cosine of pi over 2, is simply 0. So that means that this thing here will break down to 0. That is, the dot product of two vectors or two perpendicular vectors is 0. All right? Okay, that's nice. That's a good thing to know. Okay, but is this the only case where, okay, maybe before we go there, now I want us to also look at special cases using the basis unit vectors I, j, and k. Now we know that unit vector I points or is along the x-axis, while that of j is along the y-axis, and then k is a unit basis vector along the z-axis. Sorry, I'm coming. Along the z-axis, so let's make that out. Okay, great. Now, using that right there, we know that these three axes are perpendicular to each other. Let's say this to that is 90, and then this to that is 90, and then this to that is 90. In that case, if you are looking at two vectors which are perpendicular to themselves, we could simply just look at unit vector I dot unit vector j, because these two unit vectors are perpendicular to each other. Using this same result, that the angle between them is 90 degrees, we can also conclude that their dot product will be 0. So maybe let's put that out. Unit vector I dot unit vector k is the same thing as unit vector j dot unit vector k, and all these will give us 0 because these unit vectors are perpendicular to each other. Okay, great. So that is the special result we can have. It's also a very, very important one. Again, it helps us to evaluate dot product of two vectors given the vectors, that is for particular examples, which we've looked at in the next video in this series. Okay, so let's think about the next kind of property we should see. Okay, see, I'm coming. I want to find out what we are missing. Okay, I've looked at distributivity. Now I want to think about this. Now we know that if two vectors a and b are perpendicular to each other, their dot product will be 0. But is this the only case where we can get 0? Okay, of course not. Now the dot product a and b can give us 0 can also give us 0 if either the vector a, okay, is the 0 vector, or vector b is the 0 vector. All right, so, or maybe both of them. So if any of these two vectors is a 0 vector, we could also get 0. Or then or another case is that if these two vectors are perpendicular to each other, we could also get the 0 vector as a result. Or we could also get 0 as a result, because the dot product of two vectors is not a vector but rather just a number. Okay, these properties are important, and we also have very important ones. All right, now maybe let's just make this let's just know this last thing. Now using this definition right here, okay, if you are given the two vectors, okay, and then you're given their length, you want to find the angle between them, we could easily just use it. We could say cosine of theta is the dot product of those two vectors divided by their length. All right, that is from the definition which we just spelled out. And from here we could take arcsine of both sides, or cosine of both sides, that is the cosine inverse of both sides, just to get out the angle. Okay, that will give us that. Okay, and then AB. So, all right, thanks for watching. Hope you enjoyed the video. Please don't forget to subscribe to my channel, share the video with your friends, and we'll continue from our next video.